Alright, so once again we have gotten into the argument about propellers and Arduinos, etc., and I thought once and for all I would show you how awesome the propeller is. So I set this monstrosity up. We have 4 servos. We've got, which could be up to 32 on that cog. We've got a, well, if you had the pins to do it. We've got a ping. We've got 3 pots going into an ADC chip. We've got an LDR. We have a serial LCD from Mr. Pat running at 115.2. We've got a terminal program also running serial UART 2 directions at 115.2. We also have Bluetooth from this telephone going to a Bluetooth module. Pay no attention to the jumper wires. That was a bad desoldering issue. We've got 2 motors running on pulse wave speed control. We have a Wii nunchuck running via I2C. We have 2 24 count encoders and a television. So let's get moving here. If I start moving one of these pots, you can see the value change, 12-bit ADC. That could be up to 8 channels if you want it, or as many as you want, really. You can just keep adding chips. It's SPI. And as I turn that, you can see the, oops, wrong direction. You can see the servos change direction. As a matter of fact, I got all the servos going. All right, and this one is on an LDR. If I move my hand, right? Okay. Meanwhile, we are pinging away, and you can see right there, ping inches. 125 is infinity, and we put my hand in front of it, and holy camoly, as we move our hand around, we get our distance. In addition, you can see motor speed ramping up and down right there. Well, that's connected to this here Wii nunchuck. So if I hit the button, we turn the motors on, and you can hear them ramp. So those are ramping in the background with little pulse wave action. You can also see down here on the screen, button C is pushed, motors are on. If I were to hit button Z, well, we get a message there too. Button Z is pushed. I'm going to let off C, and then also you can see Accel X and Accelerate Y. Those are the tilt sensors of the Wiimote. But if you also notice, via serial, we also have the LCduino here from Mr. Pat, and if I move the joystick of the nunchuck, you can see the numbers scrolling by as I go. At the very same time, this is also UART serial, I might add. This is 2 directions at 115K. If you also notice here on my terminal program, I've got another count going via serial at 115.2. Just counting away for fun. That could be anything. Also 2 directions. And to polish it off, we've also got the RocketBot robot controller right here, which should be connected first. And this is set up just to go to the Bluetooth, to the prop, and then be bounced back. So if I hit a button...
You sent something. You sent something. You sent something.
So I've got a Bluetooth connection. Now, at the very same time that all of this is going on, I've also got these 2 quad encoders. And if you notice right there, I've got left encode and right encode. As I turn these with my hand, you can see the number increase and decrease. Now, I did a little math on these encoders. If these encoders were 128 counts, like a normal encoder, they could run while everything else is running here. We could spin them as fast as 38,659 RPM. 2 of them, both of them. At 24 count, these suckers can run at 206,000 RPM. So if you've got a robot running at 206,000 RPM with both motors, you could keep an eye on those while you're still running a television, 3 serial connections, and servos up to 32, depending on how many pins you got left over, while pinging a ping, while watching ADCs, and running a few ITC extra doodads. So, there you go. For the record, I've got one more serial connection, UART serial connection left over. with the cog that's running the other 3 serials. And I've actually got pins left over for it too, so I could be using maybe another screen or my MP3 player, or more encoders if you want. They just get a little bit slower, but at 260,000 RPM, you could run a whole heck of a lot of encoders there. And I've got a cog left on top of everything. So, so there's your answer right there, ladies and gentlemen, as to why I like Propeller. And there you go. Ting!